Hello again. Thank you for joining us. This is the Space Nuts podcast. My name is Andrew Dunkley, your host, and with me, as always, is Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. I'm still at large, still an astronomer.
Oh, well, both things are good.
Good, yeah, that's right.
Indeed. It's good to see you again. We're getting towards the end of what's been one of the most unusual years I think any of us have ever lived through. And we're still scratching our heads at it. But I suppose the big news this week was they've started issuing vaccine in the UK. And the first recipient made big headlines only this morning, our time. I think she was a 92-year-old UK grandmother. Probably didn't think ever in her life she'd be famous, but she's now written into history, and will be interesting to see how it goes. But fingers crossed that they're onto it, and this is the beginning of the end of this terrible scourge that's afflicted the world.
It's come too late for some. I have a 92-year-old, relative. She's the oldest relative I think I've got who passed away from COVID-19 on Sunday.
Oh, I'm sorry to hear that, sad. Fred.
Yeah, it's really sad. After such a wonderful life, and she was always in good health, and not anymore. So we all feel it. She's in the UK, of course. Yeah,
I think we've been very lucky in Australia. We've had a couple of little outbursts, but we and of course Victoria went through a terrible time, but they have come out of it. They haven't had a case for over 30 days. New South Wales is approaching that mark as well. I mean, at the moment, we're in the box seat, which is great. We're just got to wait for the rest of the world now. That's really what it comes down to.
Yes, that's right. Exactly, yeah.
Yeah. All right. 2020 aside, let's talk about what's been happening in astronomy and space science. And we're going to be today looking at Hayabusa 2, the return of a probe that was on a 6-year mission to bump into Ryugu, which it did successfully. It's brought back stuff. We'll also be looking at other stuff in the form of moondust. It looks like NASA is going to contract people to collect it for them, which I find fascinating. Why can't they just ask China? Aren't they doing it? We've got some interesting questions to deal with today. One from Laurie in the UK about the impact of life on Mars. If we were to find life on Mars, would that have an impact on humans going there? That's an interesting question. And the Superman effect. We'll tell you all about that a little later. Fascinating question from Kat. But first up, Fred, let's talk about Hayabusa 2, the probe that went on that 6 billion gazillion kilometre journey for 6 years to pick up dust.
Yeah, not much of it either, Andy. But enough for there to be a great deal of excitement. So, just recapping, this is Hayabusa 2, Hayabusa 1. I'm sure you and I talked about it when you were on the airwaves back it's about 10 years ago, I think, which brought back samples from an asteroid called Itokawa, if I remember rightly. Mm-hmm. Hayabusa 2 launched in 2014, took 4 or 5 years to get to the asteroid Ryugu, even though it is actually a near-Earth asteroid. But it had to do flyby of the Earth and all the usual stuff that we have to catch up with the asteroid and rendezvous with it, which it did in the middle of 2018. That's correct, mid-2018, went into orbit, was in orbit for 15 months, headed back to Earth at the end, I think it was in November 2019, and sure enough, arrived, flew by the Earth a few days ago, and jettisoned this capsule. So the capsule contains dust from not only the surface of asteroid Ryugu, but also a subsurface sample. And that's why there's so much excitement. It's the first time that a subsurface sample of asteroid material has been extracted and brought back to Earth. Why is that significant? Because on the surface, the asteroid material is modified by the solar radiation.
Oh, I was going to ask. Why would it be
Yeah.
different? But yeah.
It's not because it's getting rained on or anything like that, but it's had 4.6 billion years of subatomic particles from the sun, which modifies the surface even at those great distances. So what Hayabusa 2 did, and I think you and I spoke about this, it fired a projectile at the surface of the asteroid and then basically sampled the debris from that impact. Squirreled it away in its capsule in separate compartments from the surface samples, which is what you'd expect, and set off back November last year, set off back to Earth. The mothership, I guess you could call it, Hayabusa 2 itself, essentially jettisoned the capsule, which landed at Woomera on Sunday in South Australia. But the amazing thing is, the spacecraft is now on its way to its next target. It flew by the Earth at roughly 6 kilometers per second. And what I love, and let me just bring this page up.
That's fairly slow, isn't it? 6 kilometers a second.
Well, it's basically it's because it's in an orbit that is not that different from the Earth's orbit. It actually flies by at a relatively slow speed. You're quite right, 6 kilometers per second. It has to be going slow enough that the capsule will actually fall to Earth rather than just going.
I was about to say that too. That makes sense.
That's right. But what I love is, and I've just brought up the Hayabusa 2 project homepage, got a running tally of where Hayabusa 2 itself is, and after flying by the Earth on Sunday, which is 3 days ago, it is now 136 kilometers from Earth.
Live telemetry. I like it.
Live telemetry, yeah, it's great. So on its way to the next target.
So it's doing a bit more than 6 kilometers a second now, is it?
Just a little bit, yes. It's just a little bit more. Let me see. I can probably tell you 21. Actually, it's slowed down a bit. It's come down to about 4 kilometers per second relative to Earth.
Right.
But you've got to remember that the Earth's going at 30 kilometers per second around the sun. So, but it's buzzing along nicely, I have to say.
When will it get to its next target?
Well, the first one is an unusual, I think it's an L-class asteroid, which is a slightly rare type. I think that is another carbonaceous asteroid, I think, if I'm getting that. No, that's the C-class. No, it might be a stony asteroid. It will fly by that in 2026, but the target that they're really interested in, it reaches in 2031, and I think it will go into orbit around this object. It is a mini asteroid, a small one, which has a very rapid rotation. It rotates once in 10 minutes.
Wow.
And so that will be very interesting to see what this small asteroid looks like and get close-up images of it. So the cameras on board Hayabusa will no doubt be used for that. And on the way, it's going to be looking out for exoplanets, for planets orbiting other stars, presumably by using its cameras just to detect the stars and look for any dips in their brightness to find exoplanets. What an
incredible mission. I mean, 6 years to go out there, grab some dirt, come back, drop it off, like you drop off the kids at the grandparents' place, and then shoot off again to a couple of more targets and maybe solve some more mysteries of the universe. Who knows?
Maybe solve a few more, yeah. Meanwhile, the capsule is here on Earth. It is now, as we speak, I think it's either on its way or has reached Tokyo, because that's its immediate destination, where it will go into a laboratory, and it might take some months before it's actually opened up. So we will see in due course what the treasure trove of material is. Just to finish the story, Andrew, it's important because this is a carbonaceous asteroid, Ryugu, so it's rich in carbon. So as well as the rock material, the silicates, and the minerals that might be in there, there will be ice, water ice, which probably has already melted because it's now at kind of Earth temperature. And so there will be water vapor in the capsule, which I think may have already been drawn off. I think they were going to get the volatiles out as quickly as they could. But the really interesting stuff is the carbon-containing molecules, the organic material, because there is there are likely to be amino acids in there, the building blocks of life, which were formed before the solar system came into existence. Quite amazing stuff. So it's all about piecing together the history of the solar system, the history of the Earth and life on Earth, and perhaps even where our water came from. It might tell us.
Might indeed. I mean, this isn't the first time stuff's been brought back from an asteroid, but I think the last, well, one of the previous occasions, there was an issue of the capsule being breached or something, and so they weren't absolutely. I mean, they were fairly certain, but they couldn't say absolutely that the material wasn't tainted some way.
I think that might have been
it could have been.
But there is a NASA spacecraft on its way, if I'm remembering rightly, also with asteroid samples in it. Check up on that, but I think there's as well as Hayabusa, there's another one. The Hayabusa 1 did manage to bring back its samples in the end, but you might remember that the spacecraft had a fault on it, and it took this tour around the inner solar system before it got back. It had a flyby of Venus and all kinds of extraordinary things. Once again, an absolute epic journey, and all credit to JAXA, the Japanese Aerospace Exploration Agency. It's fantastic. They are
incredible people, everyone working in this industry. So you said it only brought back a small sample. How small is the sample?
I don't think they know exactly yet, but it may be 1/10 of a gram.
And they can learn something from that?
Yeah. There's probably a treasure trove of information in that. Get it under a microscope, and you'll see all kinds of wonderful things. Maybe even
Can't wait to find out. Now, I suppose after they've done this several times, they'll be able to compare notes and say, okay, well, everything's the same, or everything's very, very different.
Oh, look at this. This is very different. Yeah.
Exactly. And that in itself would be a revelation, I imagine. If everything's the same, then that suggests that perhaps these life seeds, if we can call them that, may well be more common than we think. And
ubiquitous. That's
all right. We will hopefully not too long, but we may have more to report in years to come from Hayabusa 2. Who knows? It's been an extraordinary mission thus far. You're listening.
2031.
2031. All right. Well, I'll just hang on. I'll just get my diary, sort that out. You're listening to Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Thanks for joining us. This is the Space Nuts podcast, episode 232 with Andrew Dunkley and Fred Watson. Before we get on to our next topic, of course, Christmas is so very close. And if you're looking for something different for someone who's hard to buy for, why not visit the Space Nuts shop at the spacenutspodcast.com website, click on shop, and there's a little tab on the left-hand side or a link. It says catalogue. So if you click on that, you can see everything, absolutely everything that we have for sale in our shop. It's a blank page. No, but we've got the bubble-free stickers. Now, I'm guessing that means when you put them on something, they don't get a big bubble underneath them. I don't know how they do that, but there it is. We've got the dad hats. We've got the embroidered T-shirts. We've got the embroidered women's and men's polo shirts. We've got the mugs and the hoodies. And it's getting cold over in the States, up in the Northern Hemisphere, across Europe. You need a hoodie. And it keeps you safe in the streets at night. People will go, oh, don't go near him, he's wearing a hoodie. So check it out at spacenutspodcast.com. Click on the shop link and then click on catalogue for all the bits and pieces that we have for sale. And let us know if you get something and send it to us. We'll autograph it maybe, and probably not send it back because I want one too. Now, Fred, let's move on to the next story about collecting moon dust. It looks like NASA is going to be issuing contracts for companies to go and get dirt from the moon for them. Is that correct?
I think that's the bottom line. Andrew.
All right.
Yeah. And what's extraordinary is that the prices that we're talking about for these contracts are not high. In fact, one of them is $1.
Right. So they're going to pay. They're going to pay a company $1 to go to the moon and grab some dirt and bring it back.
Well, that's the intriguing bit, and I'm not clear from this story about the bringing back bit. I suspect it might stay there. Because bringing it back is a huge enterprise. Yeah. So just reading through what the details are, I'm now reading a little bit between the lines, but I think the stuff stays there. So it's really all about commercial space flight, about NASA showing that the commercial sector can contribute in a major way to assisting with the exploration that NASA itself carries out. So there are actually 4 contracts, Andrew, which have been awarded to 4 different companies, and they're all different. It's really interesting. They're all rock bottom prices. Let me just read from the press release. The contracts are with Lunar Outpost of Golden, Colorado for $1, iSpace Japan of Tokyo for $5,000, iSpace Europe of Luxembourg for $5,000, and Maston Space Systems of Mojave, California for $15,000. And these samples of moondust will be collected during uncrewed missions that are already scheduled to go to the moon in 2022 and 2023. So that is the deadline for this work. But those missions, as I said, are already scheduled, and I think they're part of a much bigger suite of commercial programs which are designed to assist NASA with its Artemis project, the project to land humans back on the moon by 2024. So the deal is that these firms will collect small amounts of the lunar regolith, that's the lunar soil, but also to provide imagery to NASA of the collection and collected material. So that's essentially saying that they don't have to bring it back. But then the ownership of this soil will be transferred to NASA, and it will become the sole property of NASA for the agency's use under the Artemis program. So it's really interesting. A little bit more about this from NASA's acting associate administrator for international and interagency relations. His name is Mike Gold. He says the precedent is a very important part of what we're doing today. We think it's very important to establish the precedent that the private sector entities can take these resources, but NASA can purchase and utilize them to fuel not only NASA's activities, but a whole new dynamic era of public and private development and exploration on the moon. We must learn to generate our own water, air, and even fuel, he said. Living off the land will enable ambitious exploration activities that will result in awe-inspiring science and unprecedented discoveries. Human missions to Mars will be even more demanding and challenging than our lunar operations, which is why it's so critical to learn from our experiences on the moon and apply those lessons to Mars. And one other interesting aspect of this, Andrew, and this is once again Mike Gold going on with what he said about this, but it's how it relates to the law, space law. He says we want to demonstrate explicitly that you can extract, you can utilize resources, and that we will be conducting these activities in full compliance with the Outer Space Treaty. That's the precedent that's important. It's important for America to lead, not just in technology, but in policy. So, that's a really interesting aspect of this whole thing. And there's a comment made by Phys.org, one of the news websites. The United States is seeking to establish a precedent because there is currently no international consensus on property rights in space, and China and Russia have not reached an understanding with the United States on the subject. So,
well, we saw the space law, if you like, challenged recently with NASA, with Russia's claim to Venus, wasn't it?
Yeah, that's right. Although that was probably, again, a bit tongue-in-cheek. And I think these $1 contracts are also a bit tongue-in-cheek, I have to say. But you can see where it's going. That's the thing. That you can see that it's all about demonstrating that you can, within the law, you can do things that allow the commercial sector to participate. And the Outer Space Treaty itself actually says that that space is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. So you can't own anything in space, but you can clearly own space stuff. That's what, if you extract it, you can own it. That's actually legislation that was passed a few years ago in the United States and in a couple of other countries, Luxembourg and the UK, if I remember rightly, that if you actually go and grab something, then it's yours, even though you can't own the landscape itself.
So you can't shove your flag into the lunar surface and say, we claim this satellite on behalf of the United States of America and make it ours, like we did with countries. But you can go up there with your bucket and spade, fill the bucket up and bring it back and say, I own this moondust. It's mine.
Put a flag in the bucket. That's what you could do.
But that's the reality of it. You can't own the moon, but you can own whatever you take off it.
You can own what you
It opens up a whole can of worms when it comes to digging up, to mineral rights, for example.
Yeah, exactly. That's right. The mineral rights. You can't have mineral rights, but if you own if you dig up the minerals, you own them, according to this new paradigm, which, as it says, is not accepted universally. It's a few countries saying, well, this is the way we want to do it, but there isn't yet, I don't think, an international consensus on it.
Is it time? Should we really be starting to work this out now? Get everyone on the same page, because otherwise, with the technology that's advancing and the number of nations that are now capable of getting to the moon, you've got China, you've got India, you've got probably Israel, you've got the UK, you've got Australia that's now got looking at getting into it. Japan, the list is getting longer and longer, and it's getting easier to do, even though it's still rather expensive, but not as expensive as it used to be on a per capita basis, I suppose. But it's going to reach that point where someone has to come up with something to say, okay, here are the rules, everybody. No forward passing in football ever again.
Yeah, that's right.
Whatever it's American. Means. I was just having a crack at American football because they pass it forwards.
Yeah. Yeah. So yes, exactly. Look, I think you're right. I think it's not too soon. Definitely. In fact, it's almost in some ways the horse has already bolted. Well, it bolted in the 1960s when NASA brought stuff back.
Well, yes.
From the moon.
And they gave one rock to each state, and they wanted them all back recently, and they can't find them. I think they found like 43 of them or something. Don't know what happened to the rest. Check the broom closet. No. But
where did you put that moondust?
So these four companies are going to go up, send something up there and collect this dust, and it's not coming back, and NASA's going to claim ownership of it. So what happens to it?
Well, I think that's the thing. It's a token gesture. Okay. But
it's a really lousy present, isn't it, when you think about it? Yeah, I got you some moon dust, but it's on the moon.
But it's on the moon, yeah. But look, I'm once again reading between the lines here. I think it's these missions are going to the area where Artemis will make its landings. So it may be that they can actually, the astronauts might be able to bring these samples back, depending on how close they are. That's speculation, but and I'm sure that's included in the deal somewhere or other, but I haven't read exactly what that.
Fair enough. Okay. Well, we'll watch with interest, but I suppose it also highlights that the private enterprise is starting to become a really big player in the space race. You've got all these companies that we've heard of, but here's a bunch of companies around the world that we've probably never heard of before that are going to be doing something extraordinary. So good luck to them. I hope they do well. I'm sure they will. This is the Space Nuts podcast. I'm Andrew Dunkley, and he's Fred Watson. I don't know. I can never remember whether he's on my left or my right when we do this. But anyway, we'll be back shortly.
Speculation.
Space Nuts.
Thanks for listening to Space Nuts. Andrew Dunkley here with Fred Watson. And a big thank you to our patrons who have been supporting us throughout the year and through some pretty tough times too. So we do appreciate that. If you would like to become a patron, there are a few ways of doing it. You can go to patreon.com/spacenuts and sign up for whatever amount you deem worthy, $3 a month, $5 a month, $10 a month to join. And of course, now you can buy 12 months in advance for the price of 10 months. I don't know how they work that math out, but anyway, that's how it works. And we're aiming to get 500 patrons. We're not quite there, but that's okay. It is optional, by the way. You don't have to do it. The other thing you can do is go to Supercast, which is another way of becoming a patron, and you can start a free trial there. And if you like it, you can sign up for multiple podcasts. So you can get Space Nuts with Space Time and Dark Sky Conversations all in one big sort of Patreon package through Supercast for $8 a month, or you can just sign up for Space Nuts and Space Time with Stuart Gary for $7 a month after a 28-day trial. So they're the options. That's how it works. But as I said, they are options. You do not have to. But if you do, we thank you for putting some money back into the podcast and keeping the lights on. It's a wonderful gesture and one we truly do appreciate. Now, Fred, we have got some questions. One of them's an audio question, so I'm going to dip my microphone and we're going to hear from Laurie, who's in the UK, in just one moment.
Hi, Fred, Gregory, Peck, and Andrew. In no particular order, Laurie here in Worcester, UK. Thanks for the fantastic podcast, which often keeps me company during my daily commute. I wonder what the impact of possibly finding life on Mars would have on the continuing efforts to put humans on that planet. I'm sure that if any signs of life were located by the rovers there, or on their way due to arrive in February 2020, then many more probes would probably follow. But would the possibility of humans travelling to the planet, then returning, having possibly contracting an alien organism, scuttle the whole human space travel thing? Anywhere further than the moon, that is. Cheers.
He brings up an interesting point, especially after we've just discussed probes going to the moon and digging up dirt. But this is something you and I have discussed several times, and the issue of sending people, and not just people, things that will have Earth-based microbes on them to other places, and the risk that might pose to potential life in those places. It is a very sticky kind of scenario to look at.
Indeed, that's right, Andrew, and you're quite right. We've talked about this before. It's covered by what are called the planetary protection rules, the PPRs, which are well elucidated. Actually, it's worth anybody who's interested in this having a look at the Wikipedia page on planetary protection, because they're set out very, very clearly there and in great detail. So the protection rules exist to do two things: prevent what's called forward contamination, which is stuff from Earth carrying microbes to somewhere like Mars, and also to prevent back contamination, which is stuff coming back from an asteroid perhaps, or certainly from a planet that could conceivably harbour life. Prevent that coming back to harm us on Earth, the runaway microbe scenario or whatever, runaway virus. So those rules are in place. Now, the most stringent ones in the forward protection category are category 4C, which cover a lander going to any area of Mars where liquid water could conceivably exist. And in the equatorial regions of Mars, even though the average temperature is minus 63 or something like that, there are places where once in a while it gets above zero. And in fact, we know as well that there are natural antifreezes in some of this water. So there are times when you can have liquid water on the surface of Mars. And so that's the most stringent. If I remember rightly, a spacecraft undergoing category 4C decontamination has to have no more than 30 microbial spores on the entire spacecraft. And these are things that you can only see through a microscope. Amazing stuff. So that's what the situation is today. But Laurie is absolutely right, and his question is right on the money, and it is in fact one that I have asked twice to luminaries in NASA. One was an astrobiologist, and one was an astronaut. And I said, so what happens to the planetary protection rules when humans go? Because we're back to microbes.
Especially this year.
We've got a few viruses as well. The answer was, and I think the answer was predicated on not finding any signs of life on the planet. So it's not quite what Laurie's asked. But if we've not found any evidence of living organisms on Mars, they said, both these people said, well, the planetary protection rules will probably be quietly dumped. You just go anyway, because and do your best effectively. You know, you can't say, well, this spacecraft can only have 30 microbes on it when it's got half a dozen human beings riding in it as well. So that all has to be, I think it's still an open question. I think how you handle the planetary protection rules for human exploration is basically still one that is for the ethicists and the lawmakers. But Laurie's point is absolutely right. If in the next couple of years, and those spacecraft which are landing in February 21, not February 2020, if one of those, and it would be Perseverance because that's the one that's kitted out with things to detect signs of life, if it found something, now it wouldn't be an unequivocal discovery of life, because it can't do that. It can just say there is very likely to be life processes here. But then what you've got to do is bring samples back and study them. And you might remember Perseverance is equipped with little canisters that it will collect material in, seal them up, and leave them in particular places where they might be picked up by future astronauts or a future robotic mission. That's the current thinking. So it's unlikely that we will have any definite proof of life on Mars before maybe 2025 or something like that. But even, something positive coming back from Perseverance next year would change the dynamic, I think, and it would raise exactly the question that Laurie's asked. What about humans going to Mars if we know that it is actually a place that hosts life? And in particular, what about Elon's plans to send humans in vast numbers to Mars in I think he's still now thinking of 2026, but he's dead keen on the idea. And really, there's nothing to stop him if he's got the technology to do it.
Well, not now that we know that there aren't any solid treaties in place to stop us doing all of this sort of stuff.
Yeah, that's right.
Yeah.
So it is a very interesting question, and you would, that's been my point all along. Certainly with colonization of Mars, I think it's a dumb idea, but even large numbers of humans going to Mars, I think we've got to tread so carefully until we know for certain that Mars is a completely lifeless planet, and it might take a long time to establish that.
Of course, we're assuming that we are the ones that are going to do the contaminating, but it's also possible that we could find something that contaminates us. We find a new pathogen that could do some significant damage. They talk about the ice caps keeping certain bacteria under control, but keeping it frozen. And they're worried that some of that might get released. Ancient stuff we're talking about, and getting back into the human population. There's nothing to suggest that it might not happen in space.
Yes, that's right. Exactly. The same sort of thing. Yeah, very interesting.
Very, very interesting.
Great question, Laurie.
Awesome question. Yeah. Really, really good question. Thank you, Laurie, and good to hear from you. Let's move on to our final question for this week. This one only turned up a day or two ago, but we both agreed that it was a fascinating question and one that makes you ponder. And I know a lot of people will react instantly and go, well, no, can't happen. It's just not on, and fair enough. But it's worth discussing. Hello, Professor Watson and Mr. Dunkley. Mr.? That's my dad. Good day, and hope you and your family and all at Space Nuts are safe and healthy. I discovered Space Nuts only yesterday, and I'm already hooked on it. Obviously, it listens to no other podcasts in the world whatsoever. Now, your conversations are the perfect blend of fact and fun that makes it easy for lay people like me to understand a subject as complicated as space. Thank you so much. I started with your episode on exoplanets, and I'm going into them one by one. I hope to catch up on all episodes soon. Should only take you 5 minutes. So without further ado, here are my questions, of which there are many. In the movie Superman, the first one starring Christopher Reeve, Superman flies around the Earth in the opposite direction of Earth's rotation so fast that the Earth stops for a few seconds and then starts spinning backwards and then starts spinning forwards again when Superman flies again in the direction of Earth's rotation. What happens then if that time goes backwards, reversing the events that happened, leading to Lois Lane's death, allowing Superman to arrive at the precise moment to halt the events that would lead to her untimely death? I think it was a rock fall of some kind. Now, here we go. If the Earth were to stop its rotation for a few moments, would time stand still? What would happen to gravity then, and the moon, and all the weather systems? That's question one. Are we going to just read the lot out and then go back through them? I think so. If Earth were to spin backwards, would time be reversed? What would be the effect on gravity in such a case? If Earth spins backwards, say for a duration longer than a day, would the reversal of movement be only on its axis or along the orbit as well? Would Earth move backwards a bit in its orbit also? And is time on Earth a function and only a function of regular and periodic movement of Earth's rotation and movement in its orbit? In deep space, this is question 5, will time still flow? If so, how can it be measured? Now, those are all the questions. Some of them intertwine with each other, which we'll get to. Sorry to have put forth what might seem like rudimentary questions to you both, but I shall be delighted if you could explain it in layman's terms. Thank you so much for your podcast. I truly enjoy it, and am only sad that I didn't come across it earlier. So we take care and stay safe. With warm regards, Kat. Now, I know that basically the answer is that time started when the Big Bang started, and it will always march forward. So reversing rotation, in a nutshell, wouldn't change the forward movement of time. So we're finished. Goodbye. See you next week. No, there's more to discuss.
I wish we knew whether Cat was male or female, actually, because it would be nice to be able to use a pronoun in connection with the name. But they're great questions, actually. And, somebody has made a movie that actually utilises these precedents to make a story. But you're absolutely right, Andrew. Time is something that runs whether the Earth exists or not, and goes in only one direction. And that's actually, it's one of the interesting aspects of physics as to why it does that. Why does time only flow one way? The usual answer is that it flows in a direction of increasing entropy, which is to say the universe is becoming more disordered. It starts off very ordered because there's only hydrogen and helium in it, and ends up with all this other stuff like cars and boats and people talking on the radio, things like that. And so that's one definition. So anything that happens to the Earth happens against a background of time which is flowing immutably in the forward direction. So if the Earth, and it can't do this, but if it could spin backwards, time still marches on in the same way. And like if it did spin backwards, it would probably keep on going in its orbit in the same direction. You wouldn't have, it's going backwards, so the orbit goes backwards. It's a really good way of thinking about it, though, because you can imagine looking at a movie of the Earth spinning and going around the sun, and then reversing it and seeing what happens. And yeah, some of the consequences will be...
Well, I would
unusual.
think immediately the weather would have to change.
It would, yeah, it would certainly upset the weather. That's right. It'd probably upset the moon would probably start going in the opposite direction as well. But that's just, all that's saying is you're essentially reversing your perception of time by playing the movie backwards. Time itself is ongoing. And having said all that, though, time is probably one of the least understood aspects of physics. We do know that time is flexible. We know that things can change the rate at which time progresses. One is gravity. We've got gravitational time dilation. So our time for you and me sitting on the surface of the Earth is going at a slightly different rate from an astronaut in the International Space Station. And there's actually another phenomenon that comes in there as well, which is the relativistic velocity time dilation. If you're going very fast, to an outside observer, it looks as though time is slowing down for you, even though you yourself still feel time going at the same rate. That's all about relativity, and they're really interesting phenomena. The idea of bendy time.
Oh, it is. And you and I, Fred, in this discussion now, there's time dilation because I'm at an elevation of 267 metres, and you're nearly at sea level.
Actually, I'm not. We're at 300. No, I beg your pardon.
Oh, well, there's a difference of 67 metres. Would have a massive impact.
Meters, yeah. It would, yeah. It would make all of a what is it, a picosecond difference or something like that. But yeah, so that's all understood. We've kind of understood that for 100 years. But the phenomenon of time itself is something that you can only tinker with it in small ways by going fast or having gravitational mass, but you can't change its direction. And the reason why it's curious is that there are some physical processes, when you look at the equations for the way they work, they're perfectly symmetrical with time. And in some ways, time should be able to go backwards, but it doesn't.
Sadly for all of us.
That's right. So lovely stuff in the movies, the Earth rotating and all the rest of it. But the time really doesn't care what happens to the Earth. It just keeps marching on in its own way.
So if you could reverse the rotation of the Earth would probably still orbit in the same direction. It might have an effect on the Moon. It would definitely have an effect on the weather and other elements of life on Earth, I imagine. But in terms of time would never stop or go backwards. It would always move forwards regardless of the scenario. And it would continue to march forwards across the entire universe holistically. It's just, that's the way it is.
Yeah.
Okay. Did we cover everything? I mean, there were 5 parts to the question, but a lot of it overlapped.
Well, there was. It did. Excuse me. One of the points was what would happen to gravity. So if the Earth stopped, then people on the equator would feel a little bit heavier because there is a centrifugal effect because the Earth's rotating. Gravity is just very slightly less, but once again, it's a tiny.
It would mess up your sleep pattern though. If the Earth stopped moving, you'd have one side of the planet that would be cooked, and the other side would be freezing cold, and some people would never get to sleep because there'd never be night. Yes, it would. Wouldn't be a fun place. Yes. Would not be a fun place at all.
I don't think so. I think there might be more significant, tectonic processes that might come into.
Yeah. So you've opened up a massive cat of worms. Boom, can of worms, Cat. It's one for speculation, one that gets portrayed so well in science fiction. By the way, I've just finished writing my latest book. I'm going through the editing process now. It's going to take a long time because I suck.
Great stuff.
But it's in terms of time, it's a time movement story. And I didn't reverse the rotation of the Earth to change, to have people move through time. I used quantum computing.
Of course. You're
and nanoparticles.
Have you got entanglement?
I didn't really.
Well?
Yeah, sort of.
All right.
I kind of touch on. I don't really explain it because I don't understand it that well. But anyway, working on that one. It's a bit longer than the last one, so I've got a feeling I rushed the end, so I might have to write a bit more. I don't know yet. I'm just reading through it to see how it sounds. So far, so good. Yeah, and it's funny because you go back after you've written it, you go back and you read a paragraph or a page, and you go, "Wow, how did I think of that?" I don't know where that came from. Must have been drinking, but yeah, it's a fun process. Does that happen to you? You write something and then go back later and read it and go, "Don't remember how I thought of that."
It's weird, and because what I write is, look, I have to agonise almost over every word because it's not fiction, it's fact. And so I'm working on this children's book at the moment, and it's due for delivery next April. Hopefully published towards the end of next year. But it's a job that is a delight to do because you're talking to kids, and so I write in a way that I hope will engage them. But the facts themselves have just got to be checked to death so that I know I'm not pulling a fast one, and it makes it a slow process.
I don't have that problem. I just write a big fast one. That's what that's what I do.
Yeah.
But I love science fiction, so it's a joy to be able to put stupid ideas on paper and make them into a story.
It's fantastic. It's great that you make a contribution, Andrew. You are contributing to the literature of our country.
Yes, and when I've sold 5 copies, I'll be delighted. Yeah, it's been actually the response to the last book, which I did in audio form, has been very good. It seems to have attracted a bit of attention, so I'm very pleased about that. Yeah, so I'm now sort of toying with the idea of putting a few more on in audio format, but it's such long, hard work. It's like doing a podcast, except it's got to be perfect. Fred, we better leave it there. Thank you to everybody for listening in. Thanks for the questions, and don't forget to keep them coming. You can do that via our website, spacenutspodcast.com. Just send us a text question through the email interface, or you can click the AMA tab and record it using your very own voice. And don't forget to tell us who you are and where you're from. It's good to know. Fred, that wraps it up for another week. Thank you so much. It's been a great pleasure.
As always, Andrew, and a pleasure talking to you too, and we'll no doubt speak again next week.
We will indeed. Thank you, Fred. Fred Watson, astronomer at large, and from me, Andrew Dunkley, thanks again. See you real soon. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.